Hello and welcome to our brief overview presentation of Framestore contribution to the Present Real-Time Digital Human Research Project. The goal of Present is to create believable real-time agents that can form part of interactive experiences, ranging from filmmaking to art projects, digital avatars and TV broadcasts, or interactive agents in museums, banks, or public spaces. A fantastic consortium of research partners was brought together to try and solve the many challenges needed to realize this vision. Present at Framestore has been centered around building a fourth-generation portable digital double asset and pipeline from the ground up, taking into account requirements that it needs to extend across from VFX into real time, solving challenges for both filmmakers and our consortium partners' widely varying needs. In order to help the consortium rise to this challenge, we have primarily contributed to the project in 4 key areas: the scanning, reference gathering and building of the high-resolution digital avatar, a highly optimized machine learning approach to rig deformation, specifically targeting translation of offline rigging techniques to real-time applications, a standardized pipeline for the translation of complex pre-rendered look development to simplified real-time compatible shading models, and finally providing a flexible real-time project framework within which our consortium partners can connect their various modules and validate their differing use cases. What follows is a quick summary of 2 of those major contributions: how we achieve the visual look and the deformation performance. Let's start with the performance. When a classic VFX character is built, it is crafted from the ground up from bones, muscles, fat, skin, and hair. For being able to translate these complex offline simulation rigs into something that can run in a real-time environment, we have developed Fira. Fira is a machine learning-based system. In essence, Fira is a neural network capable of learning the complex relationship between the rig joints and the final simulated skin deformation. Once you have such a network trained, you can evaluate the state of the skin deformation for any given pose very efficiently. And by replacing the complex rig deformations with a single neural network node, this rig then becomes far more portable across multiple applications. This means that we can evaluate VFX rigs directly in Unreal Engine without any major loss in rig quality and without the need for extensive manual re-rigging. Furthermore, the efficiencies of this technique mean traditional visual effects workflows also benefit. Animators at Framestore have access to a drastically increased resolution and can instantly see the effect of their animations on the final performance. This means less iterations, less rendering, and ultimately better quality animation. Now let's quickly flip over to the visual aspects of producing a portable digital double that works across real-time and visual effects. Traditional VFX digi-doubles can be very expensive to render, with render times up to 100 hours per frame using our proprietary renderer Freak. They also require extensive artistic fine-tuning in order to look real, both during look development and animation. Texture inputs to offline rendered shaders can number in the hundreds with 4K or 8K resolution and a vast array of control parameters. So in order to convert these complex and proprietary setups designed for path tracing, we have adopted a process where we try to adhere to common standards and practices for portability in order to leverage the latest in real-time rendering. We have a pipeline that lets us process our proprietary shaders and bake them out into a much more portable PBR Uber shader representation based on the Disney Principle shader. We automatically pass our shader setups and bake them out as a series of maps. Once we have the maps, we assemble these into shaders in Unreal. We can bake for multiple different workflows and, similarly to Fira, use the result both as a preview in Maya and as a high-quality representation in Unreal Engine. The approach makes it easy to pipeline, automate, and run at scale. And here are some examples of bringing together both the machine learning rigging approach to deformation and the look development translation pipeline to produce a replica of an offline character asset, which can run within a real-time engine at interactive frame rates. Many people have worked at Framestore to make this possible, and we are grateful to them for their many and varied contributions. I'd also like to thank Cubic Motion for their close collaboration on the performance capture of the Present agent. Thank you.